All right, so we have here an introduction into simplifying complex fractions. This is from Pre-Calculus Packet 6.2, and I would really like to point out, first of all, that there is no equal sign in this particular expression, and therefore we are simplifying, we are not solving. So we will not be able to find actual value of u in this case because there is no way to do so. All we're doing is basically reducing this fraction. So what we're actually going to do here is we are going to multiply this expression by 1. And when we do that, we're going to use our fraction buster technique, only we're going to bust all 4 of the fractions in this expression with one fell swoop. We're going to do it all at once with one LCM, or least common denominator. So if I take a look at this little fella, I notice that I have a 4 as a denominator. Here's another 4, but I don't have to use it twice. Here's a 3, and there's a u. So what I'm going to do is take the 4 times the 3 times the u, and that is my multiplier. I'm going to multiply my numerator fractions times the 4 times 3 times u, and I'm also going to multiply my denominator fractions by 4 times 3 times u. And what that actually does is it multiplies by this fraction, 4 times 3 times u, over 4 times 3 times u, which is equal to 1. And of course, when you multiply by 1, you are multiplying, you're not changing the number. The value stays the same, but we are actually changing the form of the number. That's very important to remember. So what essentially happens here is that every one of these little fractions becomes multiplied by 4 times 3 times u. So let's take a moment and see what happens. On this first top left fraction, the 4 here cancels with the 4 here. So I'm left with u squared times 3 times u. Okay, so I end up with 3. U squared times u is u to the cubed, or u cubed, okay? And then when I look over here, my 4's cancel here. 4 cancels with this guy. So I end up with 3 times u times u. So I have plus 3u squared, okay? Now the denominators here have busted out, they're gone, so now I'm left with just that expression in the numerator. In the denominator here on this first fraction, the 3 cancels with the 3, so I have 4 times u, so I end up with 16u right there. And on this right fraction, u cancels with u, and I end up with 8 times 4 times 3. So 8 times 4 is 32, times 3, 64 plus 32 is 96 plus 96, okay? And if I take a look at this, now, yes, I could factor out, but that's not the point. The point is that we have simplified as far as it can go at this point, and that is our final answer. Because the point here is that we have only one numerator and one denominator, all right? This is no longer a complex fraction, so this is considered simplified. All right, so let's look at another example here. We have 1/5 minus 3/4 over 16 over x squared plus 5 over x. And it looks very intimidating initially, but we just take the time to bust this fraction by finding the least common denominator, or least common multiple of all of the fractions. So what we're going to do is we're going to take this entire fraction and we're going to check out every denominator. Here's my 5. Okay, I'm going to have 5 in my giant 1. Here's a 4. I got to include a 4. All right, here I have an x squared and here I have an x. So I have to use x squared because I can't have anything be left alone. Okay, I need to have eventually this x squared right here able to cancel. So I'm going to multiply by 1, okay, technically 5 times 4 times x squared over 5 times 4 times x squared. And when I do that, this quantity right here is equal to 1. And that is why I can distribute that to this little numerator here and this little denominator here. And I really only change the form. I do not change the value of the expression. And just as one more aside, you cannot find the value of x right now because this is not an equation, it's just an expression. All right, so let's clean this up a little bit and see what happens. All right, so if I distribute 5 times 4 times x squared, I found that especially with these complicated fractions, it helps to actually write the 5 times 4 times x squared on each of the little fellas. So I can see this 5 cancels with this. So I have 1 times 4 times x squared. So I end up with 4x squared there. And on this second fraction, now that's a minus, let's include the minus. The 4's here, this 4 cancels with this. So I end up with 3 times 5 times x squared. So that's going to be 15x squared. Okay, and that is over. Let's see, this x squared cancels with this x squared. That's why we had to use x squared instead of just x. And we end up with 16 times 5 times 4, which I believe is 320. All right, plus, okay, here's that plus. And then over here, this x cancels with one of the x's here. So there's one x left over. All right, so we have 5 times 4 times x. So 5 times 5 is 25. 25 times 4 is 100, and we have 100x. Okay, so looking at this, it is no longer a complex fraction because I have a single numerator and a single denominator. However, I do have some like terms. So I can actually simplify that a little bit further. Keep your eyes out for this kind of thing. So I get negative 11x squared in the numerator, and I can't combine any like terms here. Over 320 plus 100x. Okay, final answer. We no longer have a complex fraction, and again, you can't figure out what x is. That's okay. All right, last example, example number 3. And this one is really, really good because it has a denominator that's actually a binomial. That changes things just a little bit, okay? But not, okay? So what we need to do is look at all of our denominators and select factors that can help us make up our multiplier, or our least common denominator, least common multiple. So in this denominator, I have the factor m plus 4. So that factor just becomes part of our multiplier. Okay, and then I have the factor here of 9. Oops, that is a 4, I promise, times 9. Okay, I have a 9 here. Well, there's already a 9 there. Don't need another one. And then I have an m plus 4 here. I already have the m plus 4 here. Don't need another one. So just a reminder, we are going to multiply by 1. So we're going to multiply both numerator and denominator times m plus 4 times 9. And when we do that, remember this quantity is simply equal to 1. So we're not actually changing the value, we're just changing the form, yada, yada. Okay, so I am opting to take the multiplier and lay it next to each one of my fractions just to be able to see what cancels. If you get to a point, of course, where you don't have to do that and you just can imagine the distributive property happening, that's okay. Alrighty, so for me, I see this m plus 4 right here cancels with this m plus 4, so I'm left with 2 times 9. So I get 18. And here's a subtraction, so I got to put minus. And then in this second fraction right here, I notice that the 9 here cancels with this 9. So I'm left with 2m times the quantity m plus 4. So we do need to say 2m times the quantity m plus 4. And we'll simplify that in just a moment. Denominator. Let's look at this third fraction here, bottom left. The 9 cancels with the 9. So we have m times m plus 4. We'll rewrite that. M times m plus 4. And we do have a subtraction here, so minus. And then we end up with this m plus 4 canceling with this m plus 4, and we end up with 4 times 9, or 36, okay? Now we do have some simplifying to do once we get to this point, especially when you have the binomial denominators, okay? So let's see what happens. Alrighty, this 18, we'll start there. 18 minus, okay, so 2m times m is minus 2m squared, and negative 2m times 4 is minus 8m. Alrighty, and my denominator, m times m and m times 4, we get m squared plus 4m minus 36. And at this point, the only thing I am going to recommend is that you make sure that you're in descending order, in standard form. So I'm going to take this negative 2m squared and put it out front, minus 8m plus 18, and then put that all over m squared plus 4m minus 36. And this is as far as we go. We're not going to worry about factoring. I just want to simplify so that it's not a complex fraction, and we just have a single numerator and a single denominator. All right, please let me know if you have questions. Super cool. Thank you.